continuation of the graphical problem here. So we got the points. For this equation we got these points. For this equation we got these points. For this equation we got this point, and we need to plot these three equations on the graph. So first of all, so we don't have have the actual graph here. So I will give you the graph by drawing the lines here only. But you are supposed to practice it these things in the graph. Fine. So in the coming classes, you are supposed to be here with a graph book. Fine. I think it costs you around 10 or 20 rupees. Go and take a complete graph book and try to solve the problems by using these type of graphs. Fine. So let me draw the graph here. Fine. So this is a graph. This is x-axis and this is y-axis and this is origin. Fine. So let me make that is 10. Then it is 20, then it is 30, then it is 40, then it is, I think it is 50, and so on. Fine. Again it comes here 10, 20, 30, 40, fine. So these are the lines. So let me write the points here. What are the points I am supposed to draw? Points. It is 0, 20, and it is 40, so it is 40, 0, followed by 0, 30, and 10, 0, whereas 0, 20 and 15, 0. These are the points I am supposed to plot. Fine. So let me start plotting here. So let us take the first thing here, 0, 20. So first one point is 0, and this is what? x1, x2, or you can say this is x and y. Fine. So here x value is 0 and y value is how much? 20. So I will plot it here. So here it is again, and the next point is x and y. If I consider, that is x axis and y axis. For the x axis it is 40 here. I will plot the graph, and for the y axis it is again origin. Then these are the 2 points which are available here. So let me draw these 2 points or join these 2 points. I mean to say, draw the straight line. Fine. For which equation we have done this one? This is the equation x1 plus 2x2 is equal to 30. Fine. This is 1. The next point is 0, 30 and 10, 0. So first of all, x value is 0, y value is 30. So x value is 0, that is origin. Y value is 30, so 30 I am pointing it here. Then comes next, x value is 10, y value is 0. So this is 10 here. So these 2 lines I will join. Fine. So we have drawn this line with the help of which equation it is? 3x1 plus x2 is equal to 30. And the last remaining line is this one. So it is 0, 20, that is x is 0, y is 20 again here. Whereas the next point is x is 15. So 15 matlab the middle of this one. This is 15. So let me mark this one, and y is 0. So these are the 2 lines, 20, 15. So let me draw this one. So this line we got by which equation it is? 4x1 plus 3x2 is equal to 60. Fine. So first of all, we have started from the equation, consider those constraint as an equation, then we have found out these points. Fine. When we plot these points, the graph looks like this. Actually, if you plot the graph on the graph paper, you will come to know the exact values. Fine. So all these points have been, all these straight lines have been marked. So now we are supposed to shade the feasible region. Fine, shade the feasible region. Shade the feasible region. Shade. How we are supposed to shade the feasible region? First, consider this equation: x1 plus 2x2. Is the constraint is less than or equal to or greater than or equal to? So according to the problem, the constraint is less than or equal to. If the constraint is less than or equal to, shade the region which is below the line. So this equation is less than or equal to. So then I will shade the region below the line. So these are the regions I want to shade. Fine. The region below the line is now shaded. Done. Then go for the next equation. So next equation next equation is this. Is it greater than or equal to or less than or equal to? Fine. Fine. Check it out. The equation, this is greater than or equal to, less than or equal to. To my knowledge, it is greater than or equal to. Which equation? Which equation? This equation. That is 0, 30, 10, 30. So shade the region above the line. If the constraint is greater than or equal to, shade the region above the line. So I will shade the region above the line. So this line is shaded. Comes for the next equation. That is 4x1 plus 3x2 is equal to 60. So this equation is what? Again it is greater than or equal to. Then we need to shade the region above the line as per the algorithm. So this is the line. So we will shade the region above the line. This is the line. So this is what the feasible region. So let me remove this one. So this is not the feasible region. Fine. This is also not the feasible region. So this will become the feasible region. The common points lying within this region. So let me name this one. This will become A, and this will be named as B. Then this will be named as C, this point, and this point will be named as D. Fine. So that is A, B, C, D. This ABCD is the common region lying, called as feasible region. Fine. So what is this ABCD? Let me write feasible region. Feasible region. The feasible region is A, B, C, D, where A is equal to 15, 0, B is equal to 40, 0, C is equal to 4, 18, then D, 6, 12. But here I cannot give you exactly 12 it is, because it is a graph drawn on the plane board. If you draw the graph in actual graph, you will come across these actual values. Right? So 15, 0 is absolutely fine. 15, 0. B 40, 0 we understood. But how this 4, 8 comes in C? This is 4. Fine. So this is 4. This is what? This is 4 here. And this is what? 8. 4, I mean to 18. Sorry, 4, 18. This comes around 18. Then comes D is equal to 6, 12. So this is nothing but 12. Fine. And then this comes to 6. Almost it looks similar, but still to get the exact values, you are supposed to plot these equations or these points in the graph. So I have got these values A, B, C, D. Fine. A, B, C, D, where C and D are what? Point of point of intersection of lines. So let me show you C and D where the points get intersected. Fine. So writing all these value, putting all these value in the objective function, what happens? So substituting. So let me write this one. Substituting A, B, C, D in objective function. So what is the objective function here? That is min z is equal to 20x1 plus 10x2 is an objective function. So substitutes. So these will become points and this will becomes value of z is equal to 20x1 plus 10x2. Fine. So first one A is 15, 0. So means what? Z is equal to 20 into 15 plus 10 into 0. So Z is nothing but 300. Whereas for point B, that is 40, 0, we come across Z is equal to 20 into 14 plus 10 into 0. Then Z becomes 800. Fine. The next point is C, that is 4, 18. Then Z is equal to 20 into 4 plus 10 into 18. So it is nothing but Z is equal to 260. Whereas D is equal to 6, 12. Then Z is equal to 20 into 6 plus 10 into 12. Then Z is equal to 240. But the objective function is to be minimized. So what is the minimum Z value here? Out of this and this. Let me square this one. So as the objective function is to be minimized, what is the minimum Z value here? So minimum Z value is this one, that is minimum. So how do we got this minimum value? The minimum value we got when x1 and x2 values are 6 and 12. So let me write as objective function is minimized, therefore min value occurs at 6, 12. Hence optimal solution is x1 is equal to 6 and x2 is equal to 12. So this is what the graphical method. Fine. Thank you very much.